Greetings. Well, once again, welcome to my channel, Dear Flamingo. Before we start, if you have not still subscribed to our channel, please do that. And don't forget to turn on the post notification button, that is a small bell, so that you always receive the timely updates. You can share and like our video, interact with us in the comment section. Today, we're going to look at the physics topic, kinematics. Kinematics, or particles in motion, so to speak. Now, what is kinematics? Kinematics is the study of the motion of a particle. If you are trying to study the motion of a particle, that is kinematic. Right? Motion is a continuous change in the position of a body relative to a reference point. That is motion. So, motion is not just this. Motion can be this. Right? That is motion. The process by which you carry the whole body from one place to another is what we call locomotion, right? So that's the whole motion, right? Whether your hands or movement. Equations of motions. These are the three equations that we are going to use. So they are going to give us a question. Then we look at what we have, the ingredients or the parameters we have. Then we check whether we want to use formula 1, 2, or 3. So these are the three equations of motion that we are going to use. So over here, V is the final velocity, U is the initial or what you call starting velocity, T is the time taken, A is the acceleration, and S is the distance or displacement. So in this topic, we are going to look at uniform motion, we're going to look at vertical motion and gravity, and we'll look at the concept of projectiles, range of bodies, and its associates, right? So let's look at some notes here. If a body moves from rest, its initial velocity is 0. So what is rest? So I stand here, there is rest. If I move, my initial velocity is what? 0. Now, if a body comes to rest, you are going and you decide to come to rest, your final velocity is 0. Because you stop there. So when we check our final velocity for that's 0. So when a body starts with, that is initial. A body comes to, right, you can see that you are from somewhere and you are coming in. So in the question, you may come across this technical words here, right? Then we have to put meaning to them. Welcome. Now let's look at the sample question. Let's go. A body accelerates uniformly from rest. So that's the key word. Tells us something, right? And covers a distance of 180 meters in 6 seconds. Calculate the magnitude of its acceleration. A body moves from rest, right? So the solution to this problem, initial velocity, that is U, that is 0. It covers a distance of 180 meters. That is distance. It is denoted by S. And in 6 seconds, that means to be my time. That is 6. So the question did not give me U. How do I know U is 0? I was told from rest. If the body leaves rest, the initial velocity is what? 0. Okay. So now I have U, I have S, I have T. Then you ask yourself, so which kind of equation of motion will I use? I have U, I have S, I have T. Okay, I'm tempted to believe I'll use one. It's not going to work because I have no S here. I want to use, oh, there's S here, but there's no T here. The best equation of motion to use is the second one. Right? So using the specific S equals UT plus half AT what? Squared. Now, what is the distance? 180. U is 0. T, I don't know. That is half. The acceleration of the body is what I'm looking for. I know T, 1, right? T is 6. Acceleration, we don't know. There is also what? 6 squared. So there is 180 equals, there is 0, right? So there is 36. How do you know that? So I can write down again. 36. 2 will go here what? 18 times, right? So 180 equals what? 18A. That's acceleration. So I want acceleration. I just have to divide through by what? 18. My acceleration will come out. What acceleration here? So that is 10 meters per second squared. Remember the units for acceleration. This is meter per second squared. And this is called meter per second. So take note, right? So meter per second, is it? Or you do this. This 10 means M up, S down. That is the meaning, right? Good. A body of mass 15 kilograms. So if this is in grams, you'll be changing to kilograms, right? We're making it in standards. A body of mass 15 kilograms moving with a velocity of that is what you have. It's your initial. Are you okay? Good. It's retarded. Retardation is the negative of acceleration, right? When you're not going forward, you are retarded. That's negative. So when you do retardant calculations, you get negative. The negative sign there means that is coming back, right? Or you are decelerating. So let's go. A body of mass 15 kg. Where is the mass? The mass is 15 kilograms. Moving with a velocity, that should be my initial velocity. And that is u. 10 meters per second. 10.0 is the same 10, right? It's retarded uniformly to rest. To rest. Right? Something is going on there, right? The time is what? 2 seconds. To rest. So if to rest, then our V can be 0. That's the body comes to rest. Are you okay? Good. So the final velocity here, that is V. 0 meter per what? Second. Calculate the retarding force. So I'm looking for what? Force. Question mark. The best thing for you to do. So you have your parameters. You see, find force. That's the first thing you have to do. Just look for force. Force is defined as mass times what? Acceleration. That's the definition for force. You ask yourself, do you know your mass? The answer is yes. Do you know your acceleration? No. It means I need the acceleration before I can finish my force. So I go looking for acceleration. That is how to solve. But if you just want to read this question, you think the question itself should tell you what to do, it's not going to work. When you read the question, list the parameters out. After listing those parameters, right, quote a befitting formula. Now question the formula. I'm going to question the formula. Attack the formula. In the process of attacking, you realize that you are lacking something. Then you go looking for it. You just can't see it and say, I think I need acceleration. No, how can you think? You have to write first. Good. So I want to use this V equals U plus 80. You see, my V here happens to be 0. U was given as 10. Acceleration, I don't know. My time is 2. This is 0. This is 10. That is 2a. Right? So I can carry this here. I'll be getting negative 10 equals what? 2a over 2 over 2. So I have negative 5 meter per second squared equals what? A. What is going on? Why are you getting negative? Didn't they say they want a retarding force? So the acceleration there is a retardation or a deceleration, right? That is why it is negative. The negative sign there is just giving you a clue or it's an indication that we are decelerating, right? Okay, so you can conclude by saying A equals 5. The negative sign is telling us something, okay? Now what is the force? Mass times what? Acceleration. What is the mass? 15. Acceleration is 5. I'll get 75 for what? Newton. Why Newton? Force is in Newton. Are you okay? Good. Let's look at the next question. A car accelerates uniformly from a velocity of 15 to this. If it's from this to this, it means my initial velocity, that's the u, is 15. And my final velocity is 65 meters per second. That's the meaning. If the acceleration is 12.5, acceleration 12.5 meters per second squared, calculate the distance traveled. Distance denoted by what? S, question mark. So over here, I have U, I have E, I need S. I can't use my second equation of motion, S equals ut plus half at squared. No. I'll use the third one because I'm lacking t in the parameters here. So I picked 10. Now that is 65 squared. That is 15 squared. 2. Acceleration 12.5 all by s. Now what is 65 squared?
4225.
So we have 425. 4225. That is 225, right?
Yeah.
Plus 25s. Now 4225 minus 225 equals 25s. Now after subtracting, what are you going to get here? 400, 25s. So I have to divide both sides by what? 25. Why? Just to free my s. So what are you going to get here? 160 meters. That's how you for distance is in meter, right? Good. Question. That's a sample. What's the question? A bullet of mass 0.04 kg fired at 300 meters per second strikes a target normally and penetrates a distance of 0.20 meter through the target before coming to rest. Are you okay here? That's a technical word. Calculate the magnitude of the force exerted by the target on the bullet. We all know that we have what we call a gun recoil. When you fire a bullet, right, the bullet goes forward like this. The gun butt, that's the back of the gun, butt, it moves back, right? So when you fire 7 times, the gun butt moves back. So this way, boom, like that, right? Good. So that is what we call the gun recoil. Gun recoil. It is in line with Newton's third law of motion, right? Remember, we said to every action there is an equal and opposite reaction. I want to throw this marker over there. I can't do this and throw. It's not possible. I have to go this way and throw. So that's the opposite reaction to what I want to do. So the process by which the gun butt moves back when you fire a bullet is what we call the gun recoil. Okay? So there's a recoil question. Welcome. Solution. A bullet of mass, there's the mass of the bullet, is fired at 300 meters per second. Now that's the top speed, 300 meters per second, right? That's initial velocity. Initial velocity u, 300 meters per second. And penetrates at distance, okay, that's the distance here. Distance 0.20 meter. Now through the target before coming to rest. Coming to rest. So V is what? 0. Good. Calculate the magnitude of the force. The best thing for me to do is to quote the force formula. Agreed? In my force, I don't have my acceleration. So I go looking for what the acceleration using the third equation of motion because there's no time here. Right? So using v squared equals u squared plus 2as. So this is 0 squared. This is 300 squared. 2. Acceleration I don't know. The time is 0.20. And this is 0. This is 90,000. And 2a, not 2a, 2 by 0.2. Okay. So this is what we are getting. 90,000 plus 2 times 0.20 is 0.4 with my a. So I shift this over here. This over here. So I'm going to get negative 0.4a equals 90,000. Now I have to divide 2 by what? Negative 0.4. Negative 0.4. Good. So my a is going to give me negative 225,000 meter per second what? Squared. Now what is the significance of this negative? Over here. You see, the negative tells us that the bullet is in opposite direction to the movement of the gun. When the bullet left or went this way, the gun butt also moved back. That is the meaning of the negative. That is what we call it versus gun recoil or recoil velocity. So you have this negative sign. The negative sign means bullet is in opposite direction. Direction of bullets. So means direction of bullets, comma here. Direction of bullets. Direction of bullets is in opposite direction to the movement of the gun. That is the reason why we had that. So the negative sign is just giving us an indication, right? Our acceleration happens to be 225,000 meter per second. Now what is my force? Mass times what? Acceleration. My mass is 0.04 by 225,000. This will give me 9,000 Newton. Good. So, in case you hear about gun recoil. That is a typical question on gun recoil.